An entire season of American grain is sitting motionless on the water, not blocked by winter ice, not delayed by a lock and dam failure. Stranded on a river that has simply run out of water. As of this harvest, the Mississippi River, the single most important commercial artery in North America, is experiencing its fourth consecutive year of historically low levels. At key points, the river is functionally unrecognizable, a shadow of its former self. Billions of tons of the nation's economic output are now held hostage by a crisis happening 1,000 miles upstream. Towns in Louisiana are watching an invisible invasion of saltwater creep up the riverbed, threatening their drinking water. And the strangest part of this story is not that the Mississippi River is low. It is the scale of the failure, the systems that are breaking down with it, and what happens when the waterway that built America can no longer be trusted. To understand what is happening in the ports of Louisiana, you have to look at the sky over Pennsylvania. You must understand that the crisis is not local. The water level in Memphis is not determined by rainfall in Tennessee. It is decided by weather patterns across the Ohio River Valley, a basin draining parts of 10 states more than 800 miles away. This is the part the headlines do not capture. Zoom out, and the geography makes the mechanism clear. The Mississippi River is two distinct systems. The upper river, a series of pools controlled by locks and dams, and the lower river from Cairo, Illinois, south to the Gulf of Mexico. This lower section is a free-flowing channel, a massive gravity-fed drain for the center of the continent, operating entirely without locks. And its primary engine, the source of nearly 70% of its water, is the Ohio River. When severe drought settles over the Ohio Valley, as it did in the summer of 2022, and has continued to do in subsequent autumns, the tap is effectively turned off. The river gauge at Cairo, Illinois, is the vital sign, the point where the Ohio pours into the Mississippi. River mile 953.8 is the beginning of the problem. What happens there dictates the fate of every port, every farm, and every city downstream. The water flowing past the bluffs at Vicksburg, Mississippi, began its journey weeks before in a creek in West Virginia or a field in Indiana. The system is so vast, its inputs so remote, that by the time the river begins to fall in the south, the cause is an event that has already been unfolding for months, 1,000 miles away. An invisible drought, a hydrological ghost haunting the supply chain. And that haunt becomes a physical reality on the decks of a towboat. A standard barge on the Mississippi is a marvel of efficiency. A floating steel box, roughly 200 feet long and 35 feet wide, designed to be lashed together with others into colossal rafts called towels. Under normal river conditions, one of these barges is loaded to a draft of 9 feet, carrying approximately 1,500 tons of cargo, that is 52,500 bushels of soybeans in a single steel container. A typical 15 barge tow is a moving warehouse over 1,000 feet long, carrying the equivalent of 216 rail cars or more than 1,000 semi-trucks. An entire fleet of these tows moves constantly, a conveyor belt carrying 60% of all U.S. grain exports south to global markets. But here is the detail that tells the real story of the crisis. When the river falls, the United States Coast Guard begins issuing safety advisories, restricting how deep those barges can sit in the water. The math is brutal. Dr. Scott Stiles, an agricultural economist at the University of Arkansas, calculates the direct cost of every inch. For every single foot of draft reduction, a barge operator must offload between 150 and 200 tons of cargo. That is nearly 20,000 fewer bushels of soybeans per barge. Millions of bushels that can no longer move. The tow itself is also cut down. A 15 barge tow becomes a 9 barge tow. A 25 barge tow is restricted to 15. The river's capacity is being systematically dismantled. The most efficient transportation system on the planet is forced to become smaller, lighter, and breathtakingly more expensive. On October 20th, 22, the crisis reached its apex. The river gauge at Memphis, Tennessee, the benchmark for the entire lower river, recorded an all-time low. Not just low, but a negative value, the gauge, which measures water level against a specific reference point, fell to minus 10.81 feet. For context, low water status, the point where concern begins, is minus 5.0 feet. The river had collapsed past all known records, breaking a mark set during the legendary drought of 1988. The effect was immediate and catastrophic. Southbound grain tonnage passing St. Louis plummeted by 57% compared to the 5-year average, and the price to ship what little could move exploded. Dr. João Paulo Biazotto at the USDA's Agricultural Marketing Service tracks these numbers weekly. In mid-October 2022, the spot freight rate for a barge at St. Louis hit $47.23 per ton. The 5-year average for that same week was $16. The cost of moving grain more than doubled, and that cost was passed directly back to the American farmer through a mechanism called basis, the difference between the global futures price and the local cash price a farmer receives at the elevator. The basis widens to absorb the transportation premium, and the farmer's profit evaporates. Mike Steenhoek, the executive director of the Soy Transportation Coalition, put it starkly. When the river is restricted, the entire supply chain backs up from the Gulf of Mexico all the way to the farm gate. The images were surreal. Dozens of towboats and their barges were parked along the banks, grounded, waiting. Not necessarily stuck in the mud in the main channel. The Army Corps of Engineers works furiously to keep that dredge to a minimum of 12 feet deep, but stuck in a logistical purgatory. The river had become too narrow, too shallow in the bends and crossings, to allow for safe two-way traffic. Convoys were instituted. Daylight-only transit was mandated in critical stretches. The Continental Superhighway had been reduced to a one-lane road with a traffic cop. The total economic damage for the 2022 event alone was estimated by the American Farm Bureau Federation and the Transportation Institute at $20 billion. $20 billion. It's a number so large it's abstract. Curious what you think about that number, if it even feels real. The impact is felt in delayed shipments, spoiled grain, broken contracts, and a loss of faith from global customers who depend on American reliability. Then it happened again. The fall of 2023 saw a repeat performance, less severe, but still deeply disruptive. Projections for 2024 and 2025 show the same pattern of autumn drought in the Ohio Valley, setting up a recurring annual crisis. What was once a generational event, the 1988 drought, has become the new seasonal norm. The interval of recovery has vanished. Michael Marty Heddle, vice president at the American Commercial Barge Line, one of the nation's largest operators, now speaks of the need for year-round proactive dredging. Not just emergency response, but a permanent state of maintenance to keep the channel open against a river that is chronically diminished. The system that was built for abundance is now being re-engineered for scarcity. We go deep on stories like this every week, detailing the hidden systems that run our world. You can subscribe if you want to see them. But the problem of stranded barges is only the first crisis. Downstream, where the Mississippi prepares to meet the sea, a second, more insidious threat was emerging: an invisible invasion. From Natchez, Mississippi, all the way to the Gulf, the bottom of the Mississippi River is actually physically located below sea level. This is a natural feature, a product of geological subsidence and the levee system that prevents the river from depositing sediment and building up its own bed. Under normal conditions, the sheer force and volume of fresh water flowing south, typically between 400,000 and 600,000 cubic feet per second, acts as a powerful hydraulic barrier, holding the Gulf of Mexico at bay. It's a constant one-way battle that fresh water always wins. Until it doesn't. When the flow rate at the gauge in Vicksburg drops below about 300,000 cubic feet per second, the physics of the system begin to reverse. Seawater from the Gulf is about 2.5% denser than freshwater. It is heavier. And so it begins to slide inland, not on the surface, but along the very bottom of the river channel. It moves as a distinct solid wedge of saltwater, an underwater river flowing backwards, upstream against the current of the freshwater flowing over its top. Colonel Colin Jones of the U.S. Army Corps of Engineers, New Orleans District, described it perfectly: a slow-motion submarine intrusion. This saltwater wedge can travel for miles, for tens of miles. During the severe low water events of 2022 and 2023, it traveled over 100 miles upstream. Now here is the part nobody is putting on the news. The wedge was on a collision course with the drinking water intakes for entire parishes of coastal Louisiana. The first line of defense is in Plaquemines Parish, a long finger of land south of New Orleans. The Belle Chasse water treatment plant, along with others in the parish, pulls its water directly from the river. If the saltwater wedge reaches those intakes, the water becomes non-potable. The chloride levels spike, making it corrosive to pipes and unsafe to drink. It threatens not just homes, but major industrial facilities in places like Baton Rouge that rely on immense volumes of fresh water for their operations. Suddenly, the drought in Ohio is threatening to shut off the taps in New Orleans. The response from the U.S. Army Corps of Engineers, overseen by its commander, Lieutenant General Scott Spellman, was an act of brute force hydrological warfare. At River Mile 64, near a small community called Myrtle Grove, Louisiana, the Corps began building a mountain on the riverbed. It is called a saltwater sill, using material dredged from other parts of the river. Contractors like Great Lakes Dredge and Dock Company and Weeks Marine began constructing a massive underwater barrier, a dam made of sand and sediment. The goal was to build it high enough to block the dense saltwater wedge creeping along the bottom, while still being low enough to allow the lighter freshwater to flow over the top and continue down to the Gulf. The scale is almost impossible to comprehend. The 2022 sill required nearly 3 million tons of dredged material. That's equivalent to about 150,000 dump truckloads of sand deposited with precision on the bottom of an active river. It is a temporary megastructure, costing tens of millions of dollars with one paradoxical design requirement. It must be completely washed away by the river's own power when the spring floods return. They are building a mountain they know will be destroyed. It is expensive, it is difficult, but it is, as one Corps spokesperson noted, the only way to protect the water supply for hundreds of thousands of people. This dual crisis, barges stranded in the north, saltwater invading in the south, reveals a profound vulnerability at the core of the American economy. A single point of failure, a lack of rain in the right place at the wrong time, starts a domino effect that the rest of our infrastructure cannot absorb. When a 15-barge tow is pulled from the river, it requires over 1,000 trucks to replace it. Our highways and rail lines do not have that spare capacity. During the 2022 crisis, as shippers desperately sought alternatives, rail transportation rates for grain spiked by as much as 40%. The entire logistics network seized up. It's a system most people don't even think about until it fails. It's complex. It's vital. You could low-key send this to a friend who likes to understand how these massive systems work. And while America's grain sits in a bottleneck, its global competitors are capitalizing. The U.S. harvest season, from September to November, is precisely when these low-water events are now peaking. This is the window when 40 to 60% of our annual grain exports should be flowing to international markets. But when the Mississippi is unreliable, customers in China, Mexico, and the European Union look elsewhere. They sign contracts with Brazil and Argentina, whose own infrastructure investments have been making them more reliable suppliers. Mike Steenhoek of the Soy Transportation Coalition warns that this is not a temporary loss. Every time a customer is forced to switch suppliers, it becomes harder to win them back. Market share, once lost, can be lost permanently. The seasonal unreliability of America's primary export route is a self-inflicted economic wound, a strategic vulnerability being exploited by our biggest agricultural rivals. The engineering paradox is that the very channel the USACE maintains to make the river a superhighway for ocean-going vessels, a 45-foot deep channel from Baton Rouge to the Gulf, is the same feature that facilitates the saltwater wedge's deep, inland penetration during droughts. The solution for one problem exacerbates another. The Infrastructure Investment and Jobs Act of 2021 has allocated billions for inland waterways, and the Corps is using funds for preemptive dredging and enhanced monitoring. But this is a battle against meteorology on a continental scale. The real solution would be 6 inches of steady soaking rain across the entire Ohio Valley for a month. No hurricane can target its rain that precisely. No single weather front can fix the deficit. The NWS Lower Mississippi River Forecast Center in Slidell, Louisiana, can predict the river's fall with chilling accuracy, but it cannot make it rain in Kentucky. The system is too large, too interconnected, too dependent on a climate that is showing signs of becoming fundamentally less stable. So, 3 questions hang over the Mississippi Basin tonight. How many more consecutive years of record lows can the system endure before the economic damage becomes permanent? When does a series of temporary crises, addressed with emergency measures, become a permanent state of managed decline? And what does it mean for a global superpower when the artery that runs through its heartland can no longer be relied upon to flow? The water that fell as rain over Illinois this morning is now on an invisible clock, moving south. Somewhere in the deep, dark water off the coast of Louisiana, the dense tongue of the Gulf of Mexico is pushing north, testing the river's strength. On the river bottom near Myrtle Grove, the ghost of a man-made mountain still lies, its sediment dispersed by the last spring flood. And all along the river, from St. Louis to Memphis to Vicksburg, the dredges keep working 24 hours a day, fighting a battle against gravity and drought, scraping a channel just deep enough for the nation's harvest to pass. For now. The river is still falling. The saltwater is still pushing. And somewhere in the fields of Iowa, a farmer is watching the price of his crop tick down, his fate tied to the depth of a river 1,000 miles from his home.